In this lecture, we will introduce the NumPy library. NumPy is a basic package for scientific computing with Python and especially for data analysis. In fact, this library is the basis of a large amount of mathematical and scientific Python packages, and among them is the pandas library, which is specialized for data analysis and fully developed using the concepts introduced by NumPy. In fact, the built-in tools provided by the standard Python library could be too simple. So we have introduced the lists, dictionary lists are too simple or inadequate for most of the calculations and data analysis, but they are the basis for understanding NumPy. So having knowledge of the NumPy library is important to be able to use all scientific Python packages, and particularly to use and understand the pandas library. And actually, in the machine learning, NumPy is very important. Almost every machine learning, for example, in TensorFlow, is started with NumPy in the array. And NumPy is currently the most widely used package for the calculation of multidimensional arrays and large arrays. In addition, the package comes with a range of functions that allow you to perform operations on arrays in a highly efficient way and perform high-level mathematical calculations. So we know in basic Python, there are many functions for the mathematics and statistics, and actually NumPy also is installed with many functions. So if we create a multi-dimensional arrays, we can use the NumPy's function to do some operations. And installation and import of NumPy. So generally, this model is present as a basic package in most Python distributions. So however, if not, you can install it later. For example, in Anaconda prompt, you can use conda install NumPy. And once NumPy is installed on your distribution, to import the NumPy module within your Python session. For example, in Anaconda Spider, you can write the following statement: import NumPy SMP. So this is a standard way. Actually, almost 99.99% of the people use NumPy will use this statement. So import NumPy SMP. And ND array is the heart of the NumPy library. The NumPy library is based on one main object, ND array, which stands for n-dimensional array. This object is a multidimensional homogeneous array with a predetermined number of items. Homogeneous because virtually all the items in it are of the same type and the same size. In fact, the data type is specified by another NumPy project object called data type, and each ND array is associated with only one type of D type. So all the elements in this array will have the same data type. The number of the dimensions and items in an array is defined by its shape, a tuple of n positive integers that specifies the size for each dimension. And the dimensions are defined as axes and the number of axes as a rank. So for example, we have learned a vector, a list can be one dimension, and a matrix is for 2 dimension. For example, in mathematics, but ND array can be multidimensional. So 1x is 1 for 1 dimension. For example, the dimension is 1 to 1, 2, 3. That means it has 3 axes. The first axis has 1 size, the second is 2 sides, and the third is 3 sides. And moreover, another peculiarity of NumPy array is that their size is fixed. Such that once you define their size at the time of creation, it remains unchanged. So NumPy array is different from Python lists, is that we cannot change NumPy array for its size, for the element. We cannot change the easiest way to define a new ND array is to use the array function, passing a Python list containing the elements to be included in it as an argument. So we can create a very simple one-dimensional array called A, and we use np.array, then parentheses, and inside the parentheses, because we'll create one-dimensional array, so inside is a one-dimension list. The list 1, 2, 3, one bracket at both sides. Then we can show this array. Let's print A, and we'll show array 1, 2, 3. And you can easily check that a newly created object is an ND array by passing the new variable to the type function. So if we write type A, and Python will show numpy.nd array, that means it is an array. It is the array of the numpy ND array type. It is not a list, just it's created with numpy ND array. So its type is a numpy.nd array. In order to know the associated dtype to the newly created array, you have to use the dtype attribute. So every array has an attribute called dtype. So we use dot notation. So a dot dtype, and it will show dtype is int 32. Int 32 bits stored as 32 bit for integer this type. Actually, there are many different types of ND array in Python. And just to create the array has one axis, and then its rank is 1. While its shape should be 3, 1. To obtain these values from the corresponding array, it is sufficient to use the ndim attribute for getting the axis, the size attribute to know the array length, and the shape attribute to get its shape. So we can write a.ndim. Dim is the how many axis dimension. It will choose only one dimension. And we write a.size. Size, what means size is the odd total elements, how many elements in this array. Because it has only one dimension, and this dimension has 3 items, so its elements is 3, so the size is 3. And we can also write a.shape. The shape is 3 comma, because of one dimension, so only show this 3 here with the comma. And we can define a 2-dimensional array here. So B is a 2-dimensional array using np.array, and inside the parentheses is a 2-dimension list. So we have 2 brackets. So the outside brackets and the inside there are 2 lists. 2 lists, which 2 elements for each list. So we can use b.dtype. I will show dtype float 64, because they are float numbers. The decimal point has float number stored 64-bit type. And b and dim is a 2, because 2 axes. The first axis, the second axis. Actually, for the inside the first axis there are 2 elements, and each element is a list, so there are 2 dimension. And b.size, there are 4 elements. 4 elements are 2 times 2, 4 elements. And b.shape, shape is 2 by 2 dimension. Rank is 2. So we will show this in Anaconda Spider. We see the file called section 10, the NumPy library.py, and the link to this file will be put in the description of this video. And we move to section 1, introducing NumPy library. So import NumPy as np. We'll run this. Usually NumPy is bundled with distribution like Anaconda, so do not need to install it again. But if it's not, you have to install conda install NumPy in your prompt. And we create this NumPy 1-dimension numeric array. Then show this array 1, 2, 3, and the type A is a NumPy ND array. Then a dot type is int 32, integer 32. The dimension is 1 axis, and its size is 3 elements for the first dimension. A dot shape 3 comma. And now we create a two-dimensional array called B. Then B dot D type float 64 type. B dot N dim should be 2. And B dot size 4. And B dot shape 2 by 2.